Okay, I've got a whole page full of binomial probabilities. That will be quite easy for me if I use binomial CD. So for the first one, I've got x twiddles this. I don't know what the situation is, but I've got a value of n, I've got a value of p, and I want the probability of x being less than or equal to 16. So the possible numbers of successors always starts at 0. It's going to go up to 30. I'm interested in values near 16, so I'll put 15 in, I'll put 17 in, and I'll put ... here and here. Okay, what do I want? Well, I want anything that's less than or equal to 16. So I do want 0, I do want 15, I can equal 16, so I want 16, but I don't want 17, I don't want anything else up to 30. So I want the ones up to and including 16. So this is exactly, of course, what binomial CD tells me, the probability of being less than or equal to 16. So I do menu, 7, 3, no, not 7, 3, menu, 7, binomial CD is the first one on the second screen, and I want variable, so I want an x value. I decided I wanted to go up to 16, so I put in 16, and I've got my n is 30, and my p is, what did we say p was, 0.45, and I press equals, and the probability is p equals 0.8644. Here's my answer. Give it to 4 significant figures and I should be fine. Okay, so I've got a block of similar questions here. So the first one, I've got a new value of n, of course, and a new value of p. Now the first one, x being less than or equal to 4, well, I'll keep with the same style. So 3, 4, 5, 4, and the values on either side up to 15. I want to be less than or equal to 4, so I can have 0, I can have 3, I can have 4, but I can't have any of these others. So my box is coming like this. I want values up to and including 4, so I need to go up to 4, and I need to put in my correct values of n, which is now 15, and p, which is 0.5, and my calculator tells that I need 0.05923, so I've got the answer here. Now for the next one, we need the probability that x is greater than 4. So if I put my outcomes and I put my crosses on, okay, I don't want anything up to 4, but I want 5 and above. Now I could look up the probability that contains everything by going all the way up to 15, but that's the very largest outcome of all. So I'm actually going to sidestep using the calculator for that, because I know that the probability of all the outcomes put together is 1, and I just need to subtract away the probability of being 0 up to 4, which I could use the calculator for, but I already know the answer. It's this probability I had before. So I want the probability of everything, which is a probability of 1, minus the previous probability. So I can write 1 minus the probability of x being less than or equal to 4. That's the bit that I've taken away. And so I have to do 1 minus my earlier answer of 1.05923, which gives me an answer of 0.94077, which I can leave like that, or I could round off maybe to 4 significant figures, but that one will do. So that's that one. And the next one I've got to do is the probability that x actually equals 4. And I'm going to stick with the binomial CD way of doing things. So if I write out all my outcomes, okay, the only one with a tick is 4, because I want x to equal 4. So I've got crosses on all the others. And to capture that 4, I need a box that includes the 4, but captures the 0 to 3 as well. And I'm going to have to subtract away the probabilities of being 0 up to 3. So the calculation I'm going to need to do is the probability of x being less than or equal to 4 minus the probability of x being less than or equal to 3. And the probability of x being less than or equal to 4 actually is going all the way back to this one that I worked out before. Okay, so it's still actually there on my calculator. It was that one. And I can now go back and find the probability of being less than or equal to 3. So the only change I need to make is that I need to go up to 3 instead of 4. So if I press 3 and equals, then I get this probability of 0.017578. So I've got to do that subtraction, my previous answer, okay, and here's my probability of being less than or equal to 3. So I have to do that subtraction, which I can do by going into menu 1, and I can do 0.0592346 minus 0.01759. So there's the calculation I said I'd do. And here comes the answer, 0.04164. So the answer is 0.04164. Okay. Right, next one, probability of x being less than 7. So all the values from 0, around about 7, 6, 7, 8, up to top one is 15. I want to be less than 7. So I can be 0, I can be 6, but I can't be 7 because it's not less than or equal to, it's less than. I certainly can't be these. So the probability I want is those. So I want the probability of x being less than or equal to 6. So the x value I need to put in on here is going to be, I need to go back into binomial CD mode. There we are. So I'm going to need to put my values in afresh. So I want to go up to 6, and n is 15, has been all questioned, p is 0.5, and it tells me the probability is 0.3036. 0.3036 is the probability I want. Okay, moving onwards, I now want the probability of x being greater than or equal to 6. So I've got 0, I've got 6, 5, 6, 7 we'll go for, up to 15. What do I want? I'm not allowed to be 0, I want to be greater than or equal to 6. I'm not allowed to be 5, but I am allowed to be 6. I am allowed to be 7. I'm allowed to be anything up to and including 15. So I want all of these, but the probability I can look up is at the other end. Okay, I could put a big loop around all of them, but that would have a probability of 1. I'm just going to do 1 minus the probability of x being less than or equal to 5, getting rid of the values I don't want. So I need a fresh value of x to go up to. So I'm going to need to put x equals 5 in, and my calculator will tell me p is 0.05087. So I need to do 1 minus 0.1508. Careful. Was it a 7? No, it was actually 78, so it's 88. I'm probably going to be rounding this so it doesn't matter, but we need to be careful. So the answer is 0.84912, which I can round to 0.8491 to 4 significant figures. And finally, I've got a range with a 3 and an 8 in it, so I can go from 0, 2, 3, 4, 7, 8, 9, 15. I can't have 0. I can't have 2, but I can have 3. 3 is allowed in the range. I can have 4. I can have 7, but I can't have 8. It's strictly less than 8. So I can't have any of those either. So I can have all of these values. I need to go up to 7, but I mustn't have any of these. So those are the ones I don't want. So I need to do probability of x being less than or equal to 7 minus the probability of x being less than or equal to 2. Okay. So notice that I'm not using either the 3 or the 8 from the question. That's why you need these diagrams, so you can actually see clearly what probabilities you do need. So I don't think I've had either of these probabilities before. So same binomial distribution, same values of n and p, but I need to enter x is 7. So that gives me, well, it gives me 0.5 pretty much exactly, which I've written down. I could have predicted that actually, because the p-value is a half. So the distribution is totally symmetrical. The values from 0 to 7, there are 8 of them, okay, and the values from 8 to 15 split the distribution exactly in half. So that's why I get a probability of exactly half. The calculator, actually, because it's doing it numerically, has got 0, 0, 0, lots of zeros, and then a 4, but it should be exactly 0.5. Anyway, we've got an answer good enough for us, and we need to subtract the probability when x equals 2. So I'll put in 2, and I'll get out 0.003692. No, it's 3 at the end, isn't it? 003693. 0.003693. So if I take that answer away from 0.5, I get the final answer, which is 0.4 9, 6, 3 is going to be, and that will do to 4 significant figures. And I'm done. And I might as well just squeeze an example 2 as well. Now this says using a complement. This kind of question would be a big deal if you had to use the tables that people without your calculators are stuck with. But in fact, using a complement makes no difference at all. This probability being 0.7, I can deal with that really very happily. I've got an n of 20, I've got a p of 0.7, I've got to find the probability of, well, the outcomes are 5, 6, 7, up to 20. I want, yes, I can be 0, I can be 5, yes, I can equal 6, but I can't be any of the rest. So I am actually just working out the probability up to 6. So my x value is going to be 6. So I need a 6 there, and I need to put in the correct values of n and p. N is 20, and p is 0.7, so n is 20, and p is 0.7. Okay, and I get my probability, which is this small one here, 0.00261. P probability is 0.000261. Have I got the right number of zeros in there? Yes, I have. The next digit is actually a 0. So that's my correct 4 significant digits probability for this one.